Unit 10 is trig identities. Trig identities. Throw those words around a lot. Let's just review what both of those words mean. Trig just means we're talking about sine, cosine, tangent, and there are three reciprocal partners, which I guess I may as well write right here because we're going to review them today. Cosecant, secant, cotangent. That's what we mean when we say trig. Identities, like we use this word a lot. I don't know that we ever define it in a math class like we should. An identity is a statement that is always true. I'll give you some examples in a minute. A statement that is always true. So it looks like an equation, but it's not an equation, and by that I mean like x times x equals x squared. Like, well, yeah, I know that. That doesn't really help me solve anything, but it's a true statement. Maybe a better one would be a times x plus y. This would be the distributive property, right? Ax plus ay. That's always true. It doesn't help me solve anything, but that statement's always true. So we're going to look at some of the statements that are always true with sine, cosine, and tangent. And there's a bunch of them. We're not going to do them all today. Some of them you kind of already know. Some of them become a little bit more important tomorrow. And then we'll use them to do a variety of things. Is that a question, Brandon, or is that a stretch? It's a Monday morning stretch. Okay, before we get to the identities, let's talk a little bit about notation. Because there's a couple of, that's supposed to be a colon there. Some weird things about how we write squares and cubes with sines and cosines that throw people off. Thank you.
Do I need a...
Yes, and you can take today's notes on that first page.
Okay.
After that, it depends on how small you write. Cosine of x cubed. There's a shortcut way to write that the first time you see it, you're like, what? I'm not sure what that means maybe, but if you put the cube on the cosine, those mean the same thing. And the second way is a little bit easier because you don't have to write the parentheses. So we'll usually write it the second way. But when you see that, especially if you're thinking like I compute it in a calculator, you'd have to take the cosine of the x first and then cube it. So it's just a more efficient way of writing that. And I guess here's the confusing part, is like if we write cosine of x squared, do you know what's getting squared there? Is it the cosine or is it the x? It's the x. It's kind of an order of operations thing. But we don't really usually write that. We would usually write it with parentheses just to sort of emphasize that we're squaring the x, not the cosine. So this second column is sort of our preferred notation because it's clearer, shorter, easier. All right, 2 sets of identities today, and then we'll do some example problems. The first set is the reciprocal identities. You know these already, so these should be. Thank you. Cosecant of x. What's cosecant of x? 1 over sine. So you know that already. What we probably don't think about, it's true, but we don't use it very often. If cosecant is 1 over sine, then sine is if you rearrange this formula, 1 over cosecant. Now, you would probably be pretty rare that you would use this, because why would you replace sine with something that's like doubly more complicated? But it's a true statement. And then you could guess the next 2 lines of notes. Secant is 1 over cosine. Which means that cosine is 1 over secant. And again, you're far more likely to need the first statement than the second, because we're going to be looking at like long strings of equations and statements, and you're going to be replacing stuff. And if there's a cosine in there, almost never would you replace it with 1 over secant, because that would make things more complicated. Cotangent is 1 over tangent, which means that tangent is 1 over cotangent. I think you know those well. I hope you already know those. Maybe you hadn't thought about that second set, but they are related to the first set. Second type of identities for today, and then we'll do some example problems. Some of you got to write smaller if you're going to fit it all on today's page there, Joseph. Quotient identities. When you think of tangent, what do you think of when you think of tangent? Okay, y over x. Anything else you think of when you think of tangent? It's actually, I'm glad you said y over x, because opposite over adjacent sort of predates y over x. It's better to think y over x. But y was the sine, and the x-coordinate was the cosine. So tangent is sine over cosine. So all those times you found tangent by doing y over x, you were doing sine over cosine when you look at the unit circle. And I don't know that we said that. We just kind of stuck with y over x. But that's sine over cosine, which means that cotangent is cosine over sine. So we're going to do some examples where we replace things with some of these identities and simplify some statements. There's always more than one way to do these. So I'm looking at my prepared notes from years past, and even some of these I was like, I think I would do that differently this year. And so that if there seems to be a different way, you're right. There is a different way, and it's almost always more than one right way to get there. All of our problems today start with show that. So we're going to give you a statement that is true. We just need you to show the steps that prove it's true. Tangent of x, cosine of x equals sine of x. Now, I guess every day in math is a show your work day, but this more so than others. So even you guys that look at that and think in your head what tangent is and cross things out, and you're like, oh yeah, that's true. Well, I don't need you to just tell me it's true. I'm telling you it's true. I need you to show me how you know it's true. So again, don't look at that, think in your head, and be like, yep, check mark, we're good. Like, no, you have to show the steps. So if you're thinking that you know it's good, what substitution would you make to sort of convince yourself that it works? So replace tangent with sine x over cosine x. And then the cosines cancel. And then sine of x equals sine of x. and that's all it takes. I mean, that's the easiest possible one, I imagine. But again, it's maybe especially true on the easy ones where you're tempted to just think about what tangent is, and in your head you can cancel the cosines. Yeah, it works. I need to see that you know that it works. All right, don't write the next few things down. This is a little side path because you'll see math teachers write this down and you'll be like, what are they doing? And so I just wanted to show it to you. You don't have to write it down, but you'll see me write it down out of habit sometimes. QED stands for, I don't even know if I'm going to say this right, Latin. Quod erat demonstrandum. So that you write this after you do a proof or after you show something. Math people will write QED. Now, I don't expect you to know what quad and erat mean. I don't even know what they mean other than what it means like in full. But what does that last word look like? Demonstrated. And so basically this means, look, I demonstrated it. I'm done. I showed you my work. We're good. It's Latin for, again, you're not writing this down. You're just thinking about things. Which was to be demonstrated. And so a lot of times, math people especially, nerdy math people especially, I guess, is there any other kind of math person, I suppose, but they'll put it at the end of a proof, especially a long proof. It's like, I accomplished something. I'm going to stamp the QED on there. It makes me sound more official. It just means I did what you asked me to do. I demonstrated it. It's just a fancy mathy thing. Sometimes I'll do it. Sometimes I don't. You can do it if you want to look fancy. It doesn't matter. Like my sophomore or junior year at Baylor, we were doing an engineering one, and it was really long and whatever, and my professor finished, and of course he put the QED up there. He's like, you guys know what QED means, right? And we're like, it's Latin for something demonstrate. He's like, no, after you're working really hard like this, QED means quit and eat dinner. Haha. Math jokes. All right, back to our regularly scheduled programming here after that little Latin aside. Cosecant times cosine all over tangent equals cotangent squared. Again, everything today is true. This isn't like true or false. Is this really right or not? Like, no, it's true, but I need you to show the steps to get there. And this is one where there's multiple ways to go. I'm just kind of debating which way I prefer, but to me, if you get stuck on one, you can always put everything in terms of sine and cosine. So that's sort of a fallback, like, I'm not seeing anything here. Just stick everything in terms of sine and cosine and see what happens. So cosecant is 1 over sine. Tangent is sine over cosine. By the way, on these proofs, ideally you work on, they're not really proofs yet, sorry, I used the P word. Work on one side and work down the page, and you're working toward the other side. So you're not going back and forth, you're not adding something to both sides or multiplying something to both sides. Like algebraically that's legal, but that's not allowed in the proof or show game. We want to work on one side and make it match the other side. Let's see, so that's cosine over sine over cosine. I dropped the x's because I'm lazy. I'll put them on at the end. What do we do when we're dividing fractions? Yeah, multiply by the reciprocal, keep it, change it, flip it, any of those things. So cosine over sine times, then we flip the bottom, cosine over sine. And I'm out of room, so I'm going to break my rule about working down the page. Cosine squared of x over sine squared of x. What's cosine over sine? cotangent, and that's what we're going for. So this is cotangent squared of x. So it's a little bit like I'm giving you the answer, you just got to show your work to get there. Put a QED on that if you want to. Sine of x over tangent of x equals cosine of x. Well, again, if there's nothing sticking out, then rewrite everything in terms of sine and cosine and see what happens. In fact, why don't you try that one? I'll give you the first step. Rewrite everything in terms of sine and cosine, which would just be that tangent, and then see go from there. I think a pretty straightforward one on that one. Place tangent with sine over cosine, do the keep it, change it, flip it, and get down to cosine equals cosine. By the way, you got to show your work on these. You can't stop short, even right there. I don't want you to stop there and be like, hey, there it is, we're good. Some people will even want to stop there. Like, look, the sines cancel and the cosine flips to the top. Like, well, yes, I know that, but you have to show that. So show your work on these. Now, you wouldn't have to show that last cosine equals cosine. Maybe that's a little much, but you do need to get it all the way down to whatever the other side is. Make them match exactly. Don't make me do any work. I mean, I know it, but I need you to show it. Otherwise, we're going to get to some complicated ones where you're going to take a couple of 3 steps and be like, yeah, it works from there. And I'm going to be like, you don't know that it works from there. And you know it works from there because I told you it works, but you've got to show the steps to get there. Tangent of x plus secant of x over secant of x equals sine of x plus 1. Any thoughts? Like, again, you can always replace everything with sines and cosine. That's always an option. But I feel like there's a better first step on this one.
Cancel the secant out.
Right. Be careful when you say that because you got to divide both of them by secant. But that second one, especially when you know what your answer is, secant over secant, that's the plus 1. So let's do tangent of x over secant of x plus 1. All right, so now we're halfway there. We got the plus 1. Now I'm going to do the sine and cosine stuff on tangent, and hope that we get sine out of that. So tangent. I know I'm going to have a fraction over fraction, so that's sometimes I'll write it like this: sine over cosine over 1 over cosine. They did cancel. Secant over secant is 1. I guess what I didn't show was you could write it, but if you write them separately, you put them both over secant. And so this is where that 1 comes from. Secant over secant is 1, but that secant, you can't cancel them. Please do not just cancel those because it's all over secant. Tangent over secant and secant over secant. Is that better? Like, this is an algebra issue. Side note, x squared plus ax over x. What does that become? It does not become x squared plus a. Because it's all divided. You have to divide both of them by x. So that's the same issue. This is all over x. X squared over x is x. Ax over x is a. You have to divide both of them by x. Same thing here. You got to divide both of them by secant. Now, I'm okay if you don't show keep it, change it, flip it. If you can see from here what's going to cancel, you can do it. But there's probably people who can't, so I'm going to show the keep it, change it, flip it. And then the cosines will cancel, and we're left with sine of x plus 1. Again, you have the answers, so it's just a matter of getting there. Two more. Both of these are kind of shorter than most of the ones we've done before. 1 minus tangent of x over tangent of x equals cotangent of x minus 1. I feel like you do the right first step on this one, and it's super easy. What do you want to do first on that, with that lead in? It's similar to the last problem, especially if you start looking at your answer. Yeah, divide both of them by tangent. So that's 1 over tangent of x minus 1, which is good because now we got the minus 1 right. And now we're basically there, because what's 1 over tangent? Even better than that. 1 over tangent is cotangent. So that what you said would get you there. If you rewrote this as 1 over sine over cosine, and then you kind of rewrote it and you got cosine over sine, and be like, oh, it's cotangent. That would be fine. It would just be a little bit longer way to get there. And that's pretty common on these, actually. You work it and then you get through and you're like, oh, I could have saved myself a couple steps back there, but once it's done, it's fine.
You have to rewrite the 1 over tangent x over cotangent to be right.
Correct. Your final statement has to match the other side exactly. Okay? You can't stop short. It's not a big deal now. It becomes a big deal later when we get to more complicated ones. And some of you are going to stop 5 steps short of the final answer and be like, no, it's obvious, right? And I'll be like, to me, maybe, but I don't know that it's obvious to you. Like, if you don't get all the way there, it's sort of, it feels like you're trying to cheat. Not like copy somebody, but like you're trying to deceive me into convincing me that you knew what was going on. The other type of deception that goes on is this the other way, to just put the final answer and be like, right, like it's clear. Like, maybe it's clear, but you have to show me the work. And what you guys will do later, especially on harder ones, you'll do the first couple steps, you'll get lost, and then you'll just write the final answer and hope that I don't grade it closely enough to catch it. Hope that I just look at your final answer and be like, oh yeah, they got it, it's all good. Which also means grading these is kind of a pain, because I got to go step by step. And it's not, usually I can just look at the final answer, and if you got 37.3, then you probably took the right steps to get there. Here, since I'm giving you the answer, I really need to check your work. I can't just jump to the bottom and be like, oh yeah, they got it. Even though some of you are going to answer questions in hopes that all I do is check the final answer. This one looks awful, but it's really kind of easy. Tangent times cotangent times sine times cosecant times cosine times secant equals 1. Why is that true, or what do you want to do to show me that that's true? They're all reciprocal, so somehow you can't just be like, oh yeah, they're all reciprocals, it's true. Like, you've got to show some work here. So let's use that reciprocal thing. Tangent is 1 over, cotangent is 1 over tangent. Cosecant is 1 over sine. Secant is 1 over cosine. And now you're good. Now you've shown me that you knew they were all reciprocals and everything cancels out. So we'll close the notes with a QED there. We've demonstrated it. Your homework is Unit 10, Worksheet 1. It's the back of the notes page, and again, this is why I did this so weird, because Worksheet 1 is only one side. What's that? So try some of those tonight. Tomorrow we'll add another set of identities and then do kind of the same thing. It'll be more show problems, but you got more tools in the toolbox tomorrow.